Hey guys, nice to see all those faces. Yes. How to fly an airplane with FME, or there is a subtitle as well in how I learned to get familiar with the extensive AIXM format and that data model. So a little short presentation on me. Håkan is a Swedish name, kind of hard to pronounce, but just use the hawk in the beginning and add the N on the end, and then you have Håkan. And in many of my projects, I'm actually some kind of coordinator, and in Swedish that is samordnare, and then you have my surname. So that's me. How to stop worrying and master the AIXM data model. In the fall of 2016, me and a few colleagues of mine was in a project working with FME to enhance the performance of a lot of workspaces concerning navigational aero navigational data. And then we got the challenge to convert all of that data into AIXM. And we said, that sounds like quite a challenge. How does FME handle AIXM? And actually, by 2016, FME just added a AIXM reader and writer support, which was very nice for us. And we had to look further on what this format actually is all about. And yeah, you can read all that if you like. It's an XML-based format, which is GML enabled, so you can put all your geographical elements in there, positions and lines and areas. And the current version is 5.1.1. And one thing on this format is that you have to, it's built up on time slices, so you have to tell whether it's a base type of feature on the baseline. Upon that you can add perm deltas or temp deltas and stuff like that. If you have a construction site at the airport, when there's temporarily obstacles like cranes and stuff, you can add that upon your baseline as a temp delta, for instance, which would be valid for a few weeks while they construct all this stuff, and then it's back to the baseline level again. As has been mentioned quite a while on this conference, is that anything XML based is not very well defined. You can always extend it and put all your stuff in there, as long as you are meeting the criteria in your XSD validation file. Then you can put like whatever you like in there. But in this AIXM standards, there are like 300 features and objects. So it's, yeah, it's kind of a big model to fill out. And this is the airport heliport feature, which have a lot of subtypes connected to it. So you have to complete the organization authority, for instance, to make your airport heliport valid. You have to add this organization authority as well. So there's quite a lot of things to do to make it valid in the end. And we don't all have to do with the airport themselves. So we just have a few databases to convert. Anybody know which airport this is? No one recognizes? Oh, it's Landvetter, just outside Gothenburg. I live like 20 minutes away from it, so I hear the planes all day and all night at my house. And those databases, they are covering the entire world, so we have quite a lot to do to fill out all those elements. And that's a popsicle from last night, by the way. Thank you for a very nice party. It was awesome having world maps for dessert. I never had that before. So this is just one of the feature types, vertical structures. And in one of the databases we're converting contains obstacles, which translates into a vertical structure. We have vertical structure points and vertical structure lines. And you have to fill out all the time slices and all the name field properly and the type field properly. And in the database the data is coming from. It's not all, for instance, the name of the obstacle is not uppercase, it's camel case. So we have to sort of address that in the workspaces. And to make sure that we don't manipulate or lose data on the way, we have to store the original name of the obstacle as an extension, or we haven't made all the extensions yet, but we put it as an annotation within the AIXM format so far. And these obstacles, they have lighting, they could be lighted. So the very part in the bottom is a separate field. We separate the streams to make this light element, and then connect it again, and just before an aggregator to have those elements nested within the structure. So it looks like it's a kind of big, complex workspace, but in each and every one of those bookmarks, it's just mainly preparing one of those attributes from the database into one specific tag or field in the AIXM format. So it's not, sometimes it's just one-to-one. The text is correct from the start. In other cases, you're supposed to put a uppercase text string in the AIXM format, but the original data is a code in a numeric value. So we have to do, in some cases, we do quite a lot of mapping and comparing to meet quite many different criterias. And there is subject matter experts doing all this mapping for us, and me and my colleagues are just implementing all those mappings into this FME workspaces like this one. Yeah. We have one of the things you need in the AIXM format is as well is unique identifiers on all the features within a file, so they can't be duplicates. So we are creating UUID of whatever attribute is unique as the key from the start, and to do it all the same way in all our workspaces. We use custom transformers a lot for that. So far we have like 6, 7 custom transformers implemented in almost all the workspaces. And just the UUID generator, we see them by this the key from the feature. And we have a Python caller just to wrap that up to make the UUIDs. Yeah, that's one of the things we needed to figure out in the start. Those unique UUIDs. And we also need to keep track of the GML within the AIXM format, since the AIXM itself doesn't know what the GML is all about within it, so that you have to control yourself. But that's working quite nice. It's a very generic function within FME to do that. So that's all right. When it comes to extensions, of course you have to use the right XSD schema validation file in the end. And we have to do that a lot, since we are keeping a lot of original values that doesn't fit the AIXM model as standard. And it's nice to do some automated data quality tests. We're a team of 8 FME developers working at the same time in parallel. So we're setting up a pipeline whenever we push one of our workspaces to the GitHub, where we store them. There is a Jenkins job started. Let's see if we have a slide on. Yeah, we have a pipeline for that using Jenkins. So a job is started picking up the latest version of the workspaces and publish them on FME server, and we have a Java application for that, publishing all the workspaces to FME server using REST calls. And when that is done, it's run with a sample mode. So we write like 25 features in those the first round of AIXM file, and then we try to import them into the destination database. And that one is in a Docker container at the moment, which is very nice. It spins up quite fast, and just you import your file, get a status back, and then you can kill it again. It's perfect. And the result of those things, we use Logstash, Elasticsearch, and Kibana for monitoring the result. And you, as a developer, you get a notification quite instantly when whether you broke the workspace or not, if it's still working. So that works nice for us. So this is the a piece of a sample AIXM file. There is a sample file called which is all made up on the airport of Donlon, not London, but Donlon. So it's out there on the web to find, which is very useful to when you're trying to create bits and pieces of this format. How it's supposed to look when it's actually working, if we don't manage to get it working at once. So this is a nice thing to have access to. But the AIXM format itself is XML based and generates quite a number of rows in your output files. So a point features like this one, it's an airport heliport, which is actually a point geometry with like 20 attributes or something. And it's in a database, it's one line. In AIXM format, it's like 80 or 100 lines to make room for all that data. So it's generating very large files. When we're dealing with this obstacle data, which is point features, we generate a file with 500,000 features, and that's about 1 gigabyte of XML text file in the end. So that's we're breaking it down into smaller pieces just to be able to parallelize things in a better fashion. And we use a controller workspace, pretty straightforward, to run those workspaces on the server, and to use all of the engines on the server in a good way. We also pick out the workspace, which the heaviest one, and keep it running as a server weight set to yes within the controller workspace. So we use that engine, just not sitting there waiting for the other jobs, but it actually makes some use itself as well. Actually, we have extended this controller workspace the past weeks to add regression testing. If we don't run with sample data but with full sets, we can make regression tests reading from the original database, comparing with the AIXM file, if we lose any IDs and stuff like that on the way. So that's kind of neat. So how do you make AIXM files in a good fashion? Well, we find it very easily to wrap the most common and complex piece of it into custom transformers. And we also use GitHub. And a good thing about that is on your local machine you can make an mlink for the catalog on your local GitHub repository so you don't have to reinstall those custom transformers all the time. It actually just picks them up from the GitHub, your local GitHub. So that's a good thing. Keep that in mind. And well, we've been talking about astronauts and things the past day, and this is a Swedish astronaut as well, called Fugelsang. And perhaps he's most famous for dropping his monkey wrench into orbit. And those, the Lundqvist brothers, perhaps you know as well, they just won the World Cup in hockey just the other day. Congratulations to the silver, Canada. Yeah. Any questions so far? Yes.
The custom transformers, so those are linked, or
Yeah, we use linked custom transformers. Yes.
Want to hear my question? Okay, so no. So they're linked, and but you do work with GitHub. Do you use the versioning of custom transformers? I wondered, because you can when you make a change to a transformer, you can up the version. But I don't think that makes sense if you also work with GitHub. Because you'd have because it requires you to upgrade in the workspace as well, right? And then you need to upgrade the transformer. And if you already have your versioning in GitHub, why would you do that versioning on the transformer?
That's a good question. Why we use versioning in GitHub, and that's well, we have to use GitHub to deploy it to all of us when we do changes on the custom transformers or the workspaces. And why we use?
Well, it was more like, do you use it?
Yeah, we do. We do. So we have to, or we sort of consider that upon each change how big it is. If it's just just fixing a bug or something, then we can use the same version, same versioning of the linked custom transformer, and it's just automatically updated on all our clients. So that's how we do it. If there's a big change, we pick a new version of the custom transformer.
And then you upgrade the workspaces.
Then we update.
To be done manually, right?
Yeah. Exactly.
Great. Is there any other questions?
Hi, thanks. The UUID problem is a real challenge we found. So you were using a natural key to be able to generate the UUID. So is it always a consistent UUID you create for every natural key? And then do you have situations where the natural key changes and then you have to handle that situation?
Hopefully we don't have the natural key changing. So the next time we're on the workspace with a new read from the database, it's supposed to be the same, And those databases are certified according to the aeronautics standards, which this workspace is also supposed to be. So that's why we always keep the original attributes. We keep the key as an annotation or extension to be able to compare it afterwards.
Great. Any other questions from the audience? No? Well, thank you so much, Hagen. And thanks for rubbing in the hockey.
Yeah. You're welcome.